I want to again explain our thinking here with with an analogy. So the way, and this is part of the research that I've done for years, is that you have, again, what I mentioned, your dominant pathogens like SARS-CoV-2, but the other organisms in the ecosystems and microbiome also can act and interact with that pathogen to drive disease. And the way we look at it is it's sort of like a gang of criminals. When you have a gang of criminals, let's say, for example, or El Chapo or something like that. I don't know if everyone's watched Narcos or something, the show like that. We know Chapo, right? So he's in Colombia, he's trying to get cocaine to Miami. You know, he's literally not boarding the plane himself and delivering the cocaine. He has a whole group of people in a network that are working with him to make that happen. And so the same trend is true for chronic disease. If we only study the SARS-CoV-2 virus alone, it's a little like just following Chapo around and figuring out what he's doing. But we actually want to understand the full network of the whole criminal gang and how it fits together. And that's how we're going to get a lot of clues on the really in-depth understanding of the disease process. So again, this is an example of why this matters. This is a study by Chris Dupont, who's on our tissue analysis team, and also Jean Tan, who's a virologist, increasingly getting involved in some of our studies. And what they did is they looked at the upper respiratory tract microbiome across time in both humans and ferrets that were infected with the influenza A virus. And the uninfected humans and ferrets had a very stable upper respiratory tract microbiome. But once the infected humans and ferrets that were infected with the influenza virus, once they had that infection, they exhibited large changes in the bacterial composition of that upper respiratory tract microbiome over time that even led to the emergence of bacterial pathogens like Pseudomonas. It's a type of bacterial pathogen that began to change their activity and emerge as sort of bacterial co-infectious organisms that began to contribute to disease in the same human and ferret subjects, right? So overall, the end disease process of what they were studying, again, was the activity of the influenza virus, but also the changes that the direct infection caused to the bacterial population in the upper respiratory tract microbiome.